Moving on to our next factoring example, we have to factor this polynomial here, 4x squared plus x cubed minus x to the power 4 plus 2x plus 12. Now in this particular example, I'm going to introduce a bit of a shortcut that you can sometimes use to make the factoring process a little bit quicker. And the shortcut is going to be a combination in steps 2 and 3. Now, before getting into these factoring steps, you always want to make sure that the polynomial you're factoring is arranged from highest degree to lowest degree. So that's what we did here. We took the original polynomial and arranged it from highest degree to lowest degree. So the first step in the factoring process is we want to take out any common factors that we can initially. And in this particular polynomial, we weren't able to take out any full constants or variables. However, we were able to take out a -1 because the leading coefficient was negative. And having a positive leading coefficient just makes the factoring process a lot more smooth. So moving on to step 2, we would take this polynomial here in the bracket, which I labeled as f of x, and we would try to find factors for it using the factor theorem. And the way we do that is through trial and error. So we would plug in +1, -1, etc., until we get values of 0. So when we plug in 1 for the x value in this polynomial f of x, we get -18, so we know x minus 1 is not a factor. When we plug in -1, we get -12, so x plus 1 is not a factor. When we plug in 2, we get -24, so x minus 2 isn't a factor. However, when we plug in -2 for the x values and 3 for the x values, we get 0 for both of those. So that means that x plus 2 and x minus 3 is a factor. And here is where the shortcut comes in that I was talking about that we'll combine in steps 2 and 3. If in step 2 you find 2 factors, what that means is that if both of these individually are factors, then the product of them is also a factor. So then expanding x plus 2 times x minus 3, we get x squared minus x minus 6, and that is a factor of f of x. So now when we go into step 3, when we're dividing the polynomial by a factor, we don't have to use each of these factors separately. We can combine them and divide this polynomial by this larger factor with a degree of 2. So moving on to step 3, we have to divide that polynomial by this factor x squared minus x minus 6, which is a combination of these two factors. So I put the result here. I didn't actually show the process, I just showed the result that you get, x squared plus 2. So make sure that you pause the video and try this division and make sure you get the same result. You may actually want to refer back to the examples that we did in long division for when the divisor was a quadratic. Now, notice how because we combine these two factors, we saved ourselves a step of doing long division twice. We combined it in one. However, the trade-off is that there is a lot bigger of a chance to make a mistake. So in step 3, it's always crucial if you combine factors and divide it that the remainder that you get is always 0. You should always be getting a remainder of 0 in step 3 anyhow. However, especially when you're combining factors, it's super critical to make sure that you're getting that remainder 0, just to make sure that you haven't made a mistake with the long division. So seeing so far where we have come in the factoring process, so initially in step 1 what we did was we factored out this -1, so this -1 here was step 1. And then in step 2, what we did is we used the factor theorem to find factors of f of x using trial and error. And we ended up getting x plus 2 and x minus 3 being factors, so these were found in step 2. And then the shortcut that we did was that we combined both factors to x squared minus x minus 6, and then we divided that polynomial by that factor. And making sure that we get a remainder 0, we know that the quotient that we ended up getting in step 3 was correct. Now, you don't have to necessarily combine these factors. If you're more comfortable just doing it the longer way, just dividing the polynomials by factors with degrees of 1, you can also do that. You're just going to have to do it twice. I personally like to combine it and save myself a couple of steps. So now that we did that, we finished step 3. We have this this polynomial remaining to factor. So we go to step 4. And it says that if the quotient is a quadratic, then we can factor it using techniques we already know, quadratic formula, decomposition, etc. However, in this case, x squared plus 2 is not factorable. You can't factor x squared plus 2. There are no roots for it. You could try to put it in the quadratic formula, but the square root part will be negative. Basically, x squared plus 2, if you remember, it looks like this is just a quadratic that's shifted up by 2 units. So the y-intercept is 2. And notice how it doesn't go through the x-axis. So there are no roots to it. So you can't factor it. So this is our final result. This is the final factored form for this polynomial that we had here. So again, to save yourself time, in step 2, if you can find 2 factors, then combine them, and then in step 3, you can divide the remaining polynomial by the polynomial for when you combine the factors, and it will just save you steps in the long division.